Sometimes a single picture tells a whole story. A story of geology, of physics, and just terrifying power. We're going to break down exactly what's happening here to understand what it really takes for a mountain to just collapse. Let's get into it.
Just look at the scale of this. An entire mountainside has completely given way. It's carved this raw scar through the forest, and it stops just feet from those homes. It's a pretty stark reminder that on a long enough timeline, gravity always wins.
And that's the big question, isn't it? How does this even happen? This isn't just some random act of destruction, it's a process. So how does something that looks so solid, so permanent, just let go? Well, we're about to find out. The amazing thing is, the story of this landslide isn't hidden away somewhere. All the clues are right here, out in the open. And together, we're going to piece this puzzle together.
So, first things first, let's get the basic definition down. A landslide is simply the movement of rock, debris, or earth down a slope. Sounds simple, right? But that simple definition hides this really powerful and complex mix of forces that we're about to unpack.
The easiest way to think about it is like a recipe for disaster. You really only need 3 key ingredients. First, you need a steep slope. Second, you need some unstable material sitting on that slope. And third, you need a trigger to set the whole thing in motion.
Okay, so let's break down that recipe. We're going to start with those first 2 ingredients. These are the pre-existing conditions that can turn a totally normal hillside into a ticking time bomb. And right here, you can see our first ingredient crystal clear, a steep slope. The steeper the angle, the more of a direct pull gravity has on everything sitting on it. This isn't just a hillside anymore, it's a ramp, and it is loaded with a massive amount of potential energy.
Now, for ingredient number 2, the stuff on the slope. This isn't solid bedrock we're looking at. It's a mix of loose soil, weathered rock, and other debris. It's what geologists call regolith. This stuff has really low shear strength, which is a fancy way of saying there's not much friction or cohesion or stickiness holding it together. It's basically the perfect fuel for a landslide.
Now, here's something you might not think about. On any slope, every single day, there's this invisible battle going on. It is a constant tug-of-war, and when that delicate balance is broken, well, the consequences are catastrophic.
So on one side of this tug-of-war, you've got the forces holding everything together. That's friction between all the little particles, and cohesion, which is kind of like the natural stickiness of the soil. And on the other side, just the relentless, constant pull of gravity. As long as those holding forces are stronger, the hillside stays put.
But what happens when those holding forces start to get weaker? That's when our final ingredient comes into play, the trigger, the thing that finally tips the scales and gives gravity the win.
So the trigger is just that final push. It could be intense rainfall that soaks the soil. And it's not just about the weight of the water. The water fills up all the little spaces between soil particles, and that actually pushes them apart, which kills the friction. Or it could be an earthquake, which literally shakes everything loose. Wildfires are another one. They burn away the roots that act like a natural net holding the soil together. And of course, human activity, like construction at the base of a slope, can mess things up. Any one of these can be the final nudge gravity was waiting for.
Once that tipping point is reached, the battle is over. Gravity is won, and all that potential energy we talked about, it instantly becomes kinetic energy, the energy of motion, and on an absolutely terrifying scale. What happens next is not just a bunch of rocks tumbling down a hill. The material actually starts to flow, almost like a liquid, a super dense, fast-moving river of earth and debris. And it just builds momentum as it carves its way down the mountain, finding the path of least resistance.
So how fast are we talking about here? Some of these debris flows can hit speeds over 30 miles an hour, and sometimes a lot faster. That is way faster than any person can run. Once it starts, there is simply no time to get out of its path.
And that's the thing you have to understand. We're not just talking about moving dirt. The sheer mass, combined with that incredible speed, creates a force that is just mind-boggling. Honestly, thinking of it like a freight train, unstoppable and able to obliterate anything in its path, is a terrifyingly accurate way to picture it.
Okay, let's zoom in now to the bottom of our image, because this is where this incredible display of natural power smashes right into the human world. This is where the science becomes a very, very human story.
Just look how close it is. These homes are built right at the foot of that slope, sitting directly in the potential path of this hazard. This one frame shows you the incredible vulnerability of a community living right on the edge of a really powerful geologic process.
So now, when we look back at this image, we can read the whole story, can't we? We can see the steep slope and the loose material. We understand that invisible battle between friction and gravity, and the trigger that finally tipped the scales. And we see the devastating result when a natural event and a human community collide.
And all of this leaves us with a really critical question we have to think about. This isn't just a story about one single hillside. As our world gets more and more crowded, and we keep building in more challenging places, we have to ask ourselves, how do we decide where it's truly safe to live? What does it mean